Hi, I'm Lajak. I'm from group representative of Group E, and I am going to do our group video presentation on our group assignment on the study of the production of Lajak Kuruih tablets. We are from section 30 under Dr. NORAZLINA. Now the first task of our group, the project is to do the summarization of our data. This is our raw data. We summarize our data using the pivot table tool, and then this is the table we draw. The table we grouped it with interval of 10 milligrams, and then the highest group is this group with frequency of 61, and they are group 340 to 350 milligrams. And then same with this this graph and this table, and then the highest frequency is 37 on the group 88 to 86 and 89 to 90%. And the next one is tensile strength. The group with highest frequency is this 7.2 to 7.3 megapascal group with frequency of 47, and this one is the frequency of production shift to show that this how many samples are obtained from different shift. And then the shift that has the highest frequency is this evening shift with frequency of 72. And then we also do the numerical table that we conclude the values, the characteristic versus shift, and then with different values of such as sum, average, standard deviation, variance, maximum and minimum. And our task 2 is to help FDA to make sure that this batch of production is fulfill their requirement of the weight of the tablets should be within. We should follow the normal distribution with mean of 350 milligrams and standard deviation of 14. And this is the goodness of fit test we did. And then this is our hypothesis. Hypothesis no, the x is follow the normal distribution, and hypothesis alternative, the weight is not following the normal distribution. And then we do the table, and then we finally will get the chi-square test value to be 13.65. This is our decision rule. We use alpha as 0.05, and then hence we can have this value 11.07. as we can see that our chi-square test value is larger than the chi-square value of 0.055, and then hence we will reject HO and then conclude that this batch of tablet production is not following the normal distribution with a mean of the 350 milligrams and standard deviation of 14, so that FDA should not accept this batch of production, tablet production. And then the next task is to show that there is no difference that on the weight of the tablets that obtained from different shift. And then since we have three population of following the shift, so that we have to use ANOVA single factor test by using the data analysis tool. and then hence this is the value the output we can have. And as for here, we can have our uh, no hypothesis. All tablet weights is the mean of all tablet weights from different shift is the same, and our hypothesis alternative is at least one of the tablet weight is different, and our decision rule is reject no if p value is less than alpha, and from here we can have we can see the p value is greater than 0.05. Hence we fail to reject H no, so that there is no difference between the tablets weight get from different shift. And next is our regression analysis on the tensile strength and its relative density. And as for here, we can see that we have a fit of line fitted in the plot. So with r multiple r value have positive 0.4, which have high positive correlation of this data. And then we can have the alpha value and the beta value from this table, and then we will do a prediction to have the value of this to have the test cell value with this relative density. And then we need to make sure our regression model is correct. We did another test on need to do another test on linearity of regression tests. This is our hypothesis. The hypothesis now is beta equals to 0 to show that there is no linearity relationship between x and y, and the hypothesis alternative is b not equal to 0 to show that there is a relationship between x and y. And our decision rule is to reject h now if the significant f value is more than alpha value. Okay. And then from our data, the significant f is here. As you can see, this value is very small. It's 1.6 times 10 to the power of negative 54. It's a very small value. Hence, we can conclude that we need to reject h now as the value of significant f is smaller than alpha. Hence, we can prove that this project has strong evidence to show the existence of linearity in our regression model. This is same as the conclusion on our multiple r, which is 0.84. This is a very high correlation coefficient we have. And then we also plotted some extra plot, like relative density residual plot, and also the normal probability plot. The most important is this tensile strength versus relative density in scatter plot, and also its line fit plot. And then I think that's it for our group video presentation. Thank you for watching.